As promised, we're picking up here today and talking further about log functions. And today we're going to start with graphing. So we look at the equation of the log, and we know that if the base b is greater than 1, the graph will slowly increase. And if the base is between 0 and 1, the graph will slowly decrease. And you'll see what that looks like when we graph it right here in a minute. And do remember that since the log function is the inverse of the exponential function, this graph will have a vertical asymptote, and its equation will be x equals h, which of course will be that number right there. Okay, so here we go. Let's look at the log base 2 of x, and because b is greater than 1, we know this is slowly going to increase. Let's sketch in our vertical asymptote first. All right, since h is 0, x minus h here, you can see there is no h. So we know that our vertical asymptote is going to be right here at x equals 0. We'll sketch that in, call it a VA for vertical asymptote. All right. And now, we haven't graphed a log function, and it's a little bit different. So we're going to do this a little bit different than we've ever graphed anything before. The first thing I want to do is I want to write this in exponential form. So what is y equals log base 2 of x in exponential form? It's 2 to the y power equals x, right? So we just changed that to exponential form. Now we're going to make a table with a few values, but this time, since y is our independent variable, we're going to start by filling in the y and then calculating x. So let's say I pick negative 1 for y. 2 to the negative 1 is going to be 1/2. All right, let's go with 0. 2 to the 0 is 1. Let's pick 1 for y. 2 to the first power is 2. If I pick 2 for y, 2 to the second power is 4. If I pick 3 for y, 2 to the third power is 8. So let's graph these points. 1/2, negative 1. That'd be about right there. 1, 0, be right there. 2, 1, 4, 2, 8, 3. So here's what our graph of log base 2 of x looks like. Okay, and remember, it's the inverse of y equals 2 to the x power. So if you sketch the line in there, y equals x, and folded this graph over it, what you would get is the graph of y equals 2 to the x. All right, let's do b now. Y equals log base a third of x. Again, h is 0 in this case, so our vertical asymptote is going to stay here at x equals 0. So we'll sketch that in. That's our vertical asymptote. All right, again, I want to write this in exponential form and make a table. So in exponential form, this says 1/3 to the y power equals x. So make my table, and again, I'm going to pick y values and raise 1/3 to that power. So let's start with negative 1. 1/3 to the negative 1 power, positive 3. Pick 0. 1/3 to the 0 power is 1. Put in 1 for y. 1/3 to the first power is 1/3. And so it goes. If I plug in 2, that would give me a 9th for x. If I plug in negative 2, that would give me 9. So I really can't fit either one of those points on here. I can only get about 3 good points on this graph. We got 3, negative 1. We got 1, 0. And we got 1/3, positive 1. Let's try this. What if I put -2. If I put in -2, that would give me 9. I can almost get that on here. 9, -2, that's going to be about right there. We'll go ahead and put that there so we can draw a little bit better graph. Okay, so there's our graph of y equals log base a third of x. This one is y equals log base 2 of x. And you can see the difference in those graphs. Okay, so now in example 9, we're going to do a transformation of our parent function would be y, or f of x, equals log base 2 of x. So I'm going to go ahead and transfer these points from the graph we just did down to this graph. So we have 1/2 -1. Just moving the points from the first graph we did down here so I can do the transformation. 1/2 -1, 1 0, 2 1, 4 2, 8 3. Oops. So here we go. So I'm not going to sketch in the curve because all I really need to do now is move these points around based on my equation. All right, so what do we got here? Our A is -4. So that means we have to reflect in the x-axis and we have to stretch by a factor of 4. All right, and then here's our h. So that means we're going to go left 3, and here's our k. So we're going to go up 2. All right, so now this h here now, this h, which would be -3, right? Because it's x minus h, so x minus -3. So that's going to be our new vertical asymptote. So we're going to sketch that in first. X equals -3. So let's come over here and sketch that in. That's our vertical asymptote. X equals -3. And I understand that you may be playing me at ×2 speed, and that's perfectly okay with me. It does take a little while to sketch these graphs. All right, let me grab a different color here to make this new graph. So let's see, what are we going to do? We're going to reflect all these points over the x-axis. Okay, so I'll start with my first point here. I'll label it number 1. If I reflect it over the x-axis, its y value is now going to be 1. When I stretch that by a factor of 4, it's going to go up to 4, but then I got to go left 3, 1, 2, 3, and up 2. So that first point that I've labeled number 1, it's going right there now. Okay, the second point, which is on 1 0, great news. When I reflect it, it stays on 0. When I stretch it, it stays on 0. So all I've got to do for this second point here, which I'm labeling number 2, is to go left 3, 1, 2, 3, and up 2. So that corresponds to point 2 that I have labeled. All right, point 3, we'll label it now. Got to reflect it over the x-axis, so it'll go down to -1. Got to stretch it by a factor of 4, so it'll go down to -4. Left 3. Let's see, where was it? Hold on. 4, 1, 2, 3, up 2. So there's our number 3 point. Number 4 point, reflect over the x-axis. It'll go down to -2. Stretch it by a factor of 4. It'll go down to -8. And then left 3, 1, 2, 3, up 2. And then finally our point 8 3, I reflect it over the x-axis. It'll come down to -3. Stretch it by a factor of 4. It'll go down to -12. But then when it comes up 2, it's going to go back up to -10. And then left 3, 1, 2, 3, up 2. So here's what this transformed log graph looks like. Okay, so that is f of x equals negative 4 log base 2 of x plus 3 plus 2. All right, so it says, let's see, the domain, we can see the domain. It's not going to go beyond negative 3 in the negative x direction. So our domain is negative 3 to infinity. Behavior near the vertical asymptote. Well, I'm just going to write that in the end behavior here as x approaches negative 3. Okay, now my pen has stopped working, so bear with me here. And we're back. I think I got her working a little better now. Okay, as x approaches negative 3, f of x approaches infinity. And as x approaches infinity, because x, it does go in the positive infinity direction, f of x is going to negative infinity. Alrighty? And the range, as we can see, is all real numbers. Negative infinity to positive infinity. Okay, you can fill out the table of values down there if you want to. I'm going to leave that blank because we have our points pretty clear on our graph here, and in the interest of time, I'm just going to skip right over this table. Feel free to fill it in if you'd like to. Okay, now using inverse properties. So if you remember from the past when we studied inverses, if we did a function composition, in other words, if f and g are inverses, if I do g of f of x, it's going to equal x, and if I do f of g of x, it will also equal x. And let me show you why this is true. If I do g of f of x, that means I'm going to let b of x be the input to g. So that would be log, come on, pen, log base b. And instead of x now, I'm going to put in f of x. So b to the x. All right, so that's putting b of x, f of x into g of x, so log base b of b of x. And what does this equal? Well, I know that this means what power do I raise b to get b to the x? Well, of course, that has to be x. So that one is proven. So now let's put g of x into f of x. So f of x is b to the x. So now I'm going to put in log base b of x. And this also equals x because this one's a little bit harder to explain than the g of f of x. So what I want to do is come down here to the examples now, and maybe as we work some of these, it'll become a little bit more clear about why that is actually true. So actually, let me give you an example like this. Let's plug in some numbers. What if we have 10 to the log of 100? And so what we're saying up here is that that should equal 100, right? That's what this is saying right here. This right here. This right here. If I have 3 to the log base 3 of x, and that equals x, then if I have 10 to the log base 10 of 100, that should equal 100. So let's think about why that would be true. I just think it would be easier to explain it with tens. So let's think about this. What is the log of 100? Well, remember that's a base 10. So basically, what power do I raise 10 to get 100 to, right? So I have to, so this is 2. Log of 100 is 2. So this is equal to 10 squared, which does equal 100. So that's my kind of unsophisticated way of proving that b to the log base b of x does equal x. All right, so let's do these examples here. Let's see what we come up with. All right, so if what we've just proven is true, then 10 to the log of 2.3 is going to equal 2.3. All right, if log base 2 of 2 to the 5x is, well, we know actually what this means is if we set this equal to x, what we're saying is that 2 to some power of x equals 2 to the 5x. So I know this actually equals 5x. If you look at it up here, I know this is very strange. It's a new concept for us, but and perhaps I'm not explaining it really clearly, but take my word for it. If I've got log base 3 of 3 to the x, then I know that's going to equal x because that's just the composition of the log base 3 of x and 3 to the x. All right, 10 to the log of 29 is going to be 29. Pen not working too well here. Come on, pen. All right, so e to the natural log of 32 would be 32. This one we're going to rewrite as log base 10 of 10 to the 2x, right? That would be the same as 100 to the x, so we know that's going to be 2x. We'll do the same thing here. This is log base 3 of 3 to the 2x, so that's going to be 2x. And finally, we've got the natural log of e to the 1/2, and that's going to be 1/2. All right, because it's asking what power do I raise e to get e to the 1/2? And of course, that's 1/2. All right, so now what we want to do here is, let's see, I think this is the end of it. Yeah, I know this is long. My apologies. So let's use the composition of functions with this as f of x and this of g of x to prove that when I do the composition, I do get x in both cases. So first, we're going to do f of g of x. That means I'm going to put g of x into f of x. So what we're going to have is e to the 3, and now instead of x, I'm going to put g of x. So I got 1/3 natural log of x minus 5 plus 2. All right, and then I got to subtract 6 plus 5. Okay, so all I did there is I put this whole function g of x right in there for that x into f. G became my input. All right, so let's just simplify all this. Ooh, it looks like a mess, but let's see what we got here. If we distribute the 3 in here, we're going to get 3 times 1/3, which is 1. So that'll be the natural log of x minus 5. And then 3 times 2 is plus 6 minus 6 plus 5. So that gives us e to the natural log of x minus 5 plus 5. And we know that e to the natural log of x minus 5 is going to be x minus 5, and then we've got our plus 5, so that does indeed equal x. But now we have to prove it in the other direction. We did, this is f of g of x. Now we've got to do g of f of x, and if they both equal x, both compositions, then we know that they are inverses. So let's do g of f of x this time. So that means f is going to be our input. It's going to go in right there. So here we go. We'll have 1/3 times the natural log, and here's where we're putting in f of x. So we got e to the 3x minus 6 plus 5. And then, of course, we got to put our negative 5 in there. plus 2. All we did is we made f of x our input to g of x. Okay, let's simplify this. That gives us a third times the natural log of e to the 3x minus 6 plus 2. And I know that the natural log of e to the 3x minus 6 is 3x minus 6 because of what I learned above. So that gives me, come on, pen, write for me, 1/3. Again, the natural log of e to the 3x minus 6 is 3x minus 6. Still got our plus 2 there. So that's going to be x minus 2 plus 2, which does equal x. So we have shown that those functions are indeed inverses of one another. And that's all for our lesson today.